Two dead stars, billions of light years away. They've been slowly spiraling toward each other for millions of years. And in the final milliseconds of their collision, they release more energy than our sun will produce in its entire 10 billion year lifetime. That just happened, and we recorded it. Stop what you're doing, because what you're about to hear will completely change how small you realize we actually are. Let's talk about something called a gamma ray burst, or GRB. Scientists describe it as the most violent, most luminous, most catastrophically powerful event in the known universe. Not in our galaxy, not in our solar system, in the entire observable universe. And here's what nobody told you in school. Some of these explosions are caused by two neutron stars literally crashing into each other at speeds approaching a fraction of the speed of light. Now, before your brain skips past that, let's make it real. A neutron star is what's left behind after a massive star explodes in a supernova. It's not a regular star. It's the compressed, crushed, almost incomprehensible remnant of something that used to be enormous. We're talking about an object that packs roughly 1.4 times the mass of our entire sun into a sphere roughly 20 kilometers across. That's about the size of a city. 1 teaspoon of neutron star material would weigh approximately 10 million tons on Earth. Let that land for a second. A teaspoon, 10 million tons. Now imagine two of those things, locked in a gravitational dance, circling each other for billions of years, getting closer and closer as they bleed energy through gravitational waves, ripples in the actual fabric of space-time. Then, after all that cosmic patience, they finally collide. On August 17, 2017, something extraordinary happened. For the first time in human history, scientists detected both gravitational waves and light from the same cosmic event. The LIGO and Virgo detectors picked up gravitational waves from two neutron stars merging approximately 130 million light-years away in a galaxy called NGC 4993. This event, designated GW 170817, became one of the most studied astronomical events ever recorded. Within seconds of the gravitational wave signal, NASA's Fermi Space Telescope detected a short gamma-ray burst. The universe had just handed humanity a gift, proof that short GRBs are born from neutron star collisions. And here's where it gets controversial, and frankly, a little unsettling. That collision didn't just create a black hole and a blinding burst of radiation. It created what scientists call a kilonova. A kilonova is an explosion so rich in heavy elements that it literally forges gold, platinum, and uranium in space. The gold in your jewelry? There is a measurable scientific possibility it was forged inside a neutron star collision billions of years ago. You are wearing the debris of a cosmic catastrophe. Still think the universe is distant and irrelevant to your daily life? Now, the GRB itself, let's not underestimate this. A gamma-ray burst releases energy in jets moving at roughly 99.99% the speed of light. The radiation in those jets is so intense that if one were pointed directly at Earth from within our own galaxy, it could strip away the ozone layer, cause mass extinction-level damage, and potentially end complex life as we know it. Researchers have even proposed that the Ordovician mass extinction event, which wiped out approximately 85% of marine species around 443 million years ago, may have been triggered by a GRB. That theory is still debated, but it is scientifically on the table. Extinctions from space, not from asteroids, from light. Here's where the pattern breaks everything you assumed. We tend to think of destruction as an ending. But neutron star collisions are simultaneously the universe's most efficient element factories. Every heavy element heavier than iron, and that includes the copper in your phone, the iodine in your body, the silver in your kitchen, is believed to have been forged in environments just like these. Stellar explosions and neutron star mergers are the universe's periodic table. You are not just made of stardust in a poetic sense. You are made of the physical output of ancient violent cosmic collisions. The short GRBs produced by neutron star mergers typically last less than 2 seconds. 2 seconds. And in those 2 seconds, they outshine entire galaxies containing hundreds of billions of stars. Our instruments only began reliably detecting and classifying GRBs in the 1990s through NASA's Compton Gamma Ray Observatory. Since then, we've detected thousands. The most powerful GRB ever recorded, designated GRB 2-21009A, was observed on October 9, 2022. Scientists nicknamed it the boat, the brightest of all time. It arrived from approximately 2.4 billion light-years away and was so intense it temporarily affected Earth's ionosphere. A pulse of radiation from nearly 2.4 billion light-years away physically disturbed our atmosphere. Let that sink in. We are fragile. The universe is not. And yet, instead of this terrifying us, it should fill us with something rare, genuine, unfiltered awe. Because every time science peers deeper into these events, we don't find randomness. We find precision, structured physics, predictable outcomes inside unimaginable chaos. The laws of the universe don't break during a gamma-ray burst. They perform. If you made it this far, you're exactly the kind of person who deserves to understand the universe better than the average person scrolling past. Follow this page right now, because we go deep into the science the textbooks rushed past, and we make it impossible to look away. Now here's the question I want you to answer in the comments below. If a gamma-ray burst from within our galaxy is one of the most credible natural extinction threats to Earth, why do you think this isn't discussed more publicly, and should it be?